Hello, good evening, all.
Good evening, ma'am.
Hello, ma'am. Good evening.
So, should we start with the week two? So, how many of you are done with
Good
week two
evening, ma'am.
content? How many of you have finished week two content? Like you have watched the lectures?
Yes, ma'am, I have completed it.
I have watched the lecture, ma'am, but I am also.
Okay, all of you who has watched the lecture, just raise your hand. 2, 3, 4, 5, 6, 7, 8, 9.
Okay.
So total of 9 people have watched all the lectures. Huh? Okay. Priyanshu, okay. So what about others? Like, did you start? You all can know.
Hello.
Yeah, I started.
Hello.
Yes.
Yeah, ma'am. Actually, 2 lectures are left to watch.
Okay.
Yeah.
Okay. So last.
Yeah.
Okay. So last session we were doing the revision of like from lecture 2.1 to 2.5. That part we had done,
Oh,
right? So any one of you who has doubt in 2.1 to 2.5?
I have doubt in 2.11.
No, I'm asking from 2.1 to 2.5.
No doubt, ma'am.
No doubt. Okay. So we'll start from lecture 2.6.
ma'am, we did till 2.4, not 2.5.
Oh, we did not do 2.5. Okay.
No. 2.5 we didn't.
Ma'am, there's a doubt in one of the 2.2, section 2.2.
Section 2.2. Okay.
Yeah, AQ 2.2. I think it's AQ 2.2 where this.
Okay. Activity question will come back. Okay. First, if you have any doubt in the lecture, just let me know.
No.
I have a couple of questions. And may I go ahead?
Yeah, please. Go on.
Ma'am, we came across a term called IID, right? Hello.
Yes, we have talked.
Independent and
Yes.
identically distributed random variables, right?
Right.
So
right.
the term in independent is clear to me, like when the marginal probability of 2 random variables is equal to their joint probability, right? So then random variables are called independent random variables. The second phrase, like identically distributed. So professor is saying that for identically distributed, their marginal probabilities have to be same, right? So this statement is not clear to ma'am to me. So
Okay,
could you please explain with some concepts?
Yes.
What is meant by
right. So this part, right? IID. You will see this term again and again as you move to the
correct quite often,
next,
quite
yes. often. Yeah, like as you move
Right.
from week 8, week 7 onwards, you will see this term quite often. So you understood that IID is called as independent,
and identically distributed.
independent and identically distributed, right?
Correct.
Now, independent part is clear to you. Now, what is
Correct.
identically distributed? So,
Right.
let's say I have like, so sir has told in the lecture that the marginal should be equal. Like if I have 2 random variables, let's say x1 and x2, their marginal should be equal. So what do you mean by that, right? So their probability distribution basically, like if I have a die, right?
Ma'am, can I add something more so that my question will be more clearer? Can I add something more, ma'am? Yes.
Yeah.
Ma'am,
Yeah.
like first thing is that both x1 and x2 belong to the same probability space, right?
Yes.
x1 and x2
Yes.
belong to the same probability
Same
space,
probability
right?
space. Yes.
Correct. Now each random variable has their own range, right? Now say for example, x1 belongs to 2, 3, 4, 5. Correct. Can you write it down, ma'am? X1
Okay.
belongs to 2,
Okay.
3, 4, 5. X1, 2, 3, 4, 5. This is the value what is taking, X1 is taking. And X2, say for example, is having only 3, 4. Correct?
Okay.
Yeah. So now how I will classify this now?
Yeah. So,
So-
yeah. So first of all, you will have to check if what are the probability distribution of each of the values. Do you have anything in mind?
No, not at this point of time, ma'am. Now there I got stuck, ma'am. So I thought to clarify with you.
So
Because
basically,
the word independent is clear to me. And as you cleared my one more doubt that both X1 and X2 belong to the same probability space. So these two doubts are clear. Now in terms of marginal probability, if you explain me, then nothing like that. Yeah.
okay. So identically distributed means the distribution should be same, right? So if I'm saying I have two random variable, right? As you have written here, X1 and X2,
Hmm.
right? So if I'm saying that X1 is taking the probability or saying the values that here you have written, it is 3, 4, X2 is taking, and X1 is taking 2, 3, 4, 5. So saying that the probability distribution is equal means that, let's say if one distribution is, let's say, like the order distribution, right? Discrete distribution you're familiar with.
Yeah, on that they explained like binomial, Poisson,
All that we have
geometric,
discussed, right?
Poisson,
Yes,
okay.
ma'am.
Yeah. So the distribution should be same. So if I'm saying, let's take a very simple example. So let's say if I'm saying X1 is a Bernoulli distribution with the P value of P is, let's say, 0.2. And X2, if I say that it is Bernoulli 0.5. So they are not identically distributed. So if I would have written that both X1 and X2, like, they are both coming from same probability space, and they are, let us assume that X1 and X2 are independent. Okay. But if they follow, like, let's say X1 follows a Bernoulli 0.2 distribution and X2 follow a Bernoulli 0.5 distribution, then we will not say that X1 and X2 are identically distributed. Their distribution is different. For example,
They might be independent. They might be independent.
let assume that they are independent, but
Okay.
their distribution are not same.
Okay.
Their distribution are different. So in general, this is what we understand by like identically distributed. So both the distribution should be same. So if I take, let's say, an example of let's take very basic example. Throwing you have a, let's say you have a bias die. So X1, let's say, if you have a die, you have head and tail, and probability of occurrence of head, right? Let's say one has 0.5 and other has, let's say, if you have another dice, let's say the probability of occurrence of head is given by 0.6. So again, their distribution are not same. Okay. So these assumption, like this IIT assumptions are like later very useful in formulating some very important results in statistics.
Ma'am, didn't get this point. What you said just now.
Which one?
This had one probability 0.6.
Okay, I'm saying like if you have a unbiased die and you have a biased die, right? So the probability of occurrence, like occurrence of head or a tail, will be different in both the cases. Right?
Okay.
Like if I define probability of success to be getting a head.
For a biased one?
Yeah, both for biased and unbiased. So it will be different, right? So again, they are not identically distributed.
Okay, because they have different probabilities and
probability, yes.
Okay.
So in general, this is what we say, like what we mean by identical distribution.
Okay.
And is it possible that X1 belongs to binomial and X2 belongs to geometric? Is it possible?
No, you can there you can easily see that one one random variable is following a geometric distribution and other has a binomial distribution. So obviously
it
it
can't
is
be,
very clear
yes.
that it is not identically distributed.
Ma'am, if the probability of both the random variable is same, then it can be said that it is identically distributed.
Yes. So if I write, let's say we are just talking about two random variable here. We haven't discussed about some random variable yet. So if I'm saying that x1, x2 is IID, let's say I'm writing geometric P. Okay. So if I have written this statement, right? So if I've written the statement, it means both the random variable x1 and x2. First thing is they are independent. They both should be independent. And second should be both x1 and x2 should follow the geometric P distribution. So the P cannot be different.
Ma'am, does
It
it
has to
apply
be
to,
same.
Yeah.
ma'am, does it apply to other parameters as well? For example, it is like binomial, in that case, n and p. So n and p both should be same in case of identical p.
N should be same. Yes, both should be same. So in that case, we'll say it is binomial NP.
Right. So all the parameters, the
All
type as
param-
well as the parameter
yes,
should be same.
yes,
Okay.
yes, it should be same.
Both N and P, right, ma'am?
Both N and P. Yes.
Mhm.
Okay, ma'am, let us take that my my random variables are following uniform distribution, correct? So x1, both random variables x1 and x2 follow random uniform
Okay,
distribution.
this
right?
example. So if they both are no,
I'm now
not
I'm
this.
assigning probability also, ma'am. Now I'm assigning probability.
So
also.
if you are saying they are uniform distribution,
yeah, 2 is having 1/4, 3 is having 1/4.
yeah, so
4 is
everything
having,
is 1/4, 1/4, 1/4,
and the other one is half, and the other one is half.
half. So can you say they are identically distributed? Are the distributions same?
No.
No, right? Their
Both of them
distribution
are following uniform distribution.
one-
Both of them are following uniform distribution.
both have the uniform distribution, right?
Correct.
But
They are not.
their probabilities, if you look at the probabilities,
Probability
right,
different. Yeah.
they are varying.
Due to-
Does it mean that both the random variables must have same number of events and with same variable, same probability, right?
Same probability, right?
And same number of events, like here 2, 3, 4, 5 belongs to certain number of events, right?
Yes.
So f of x, I mean fx1 of 3 should be the same as fx2 of 3.
No, fx3 of
Sorry, can you repeat?
I was just asking if the fx1 of 3 should be equal to fx2 of 3. In this example.
Okay.
In this
fx1.
example.
Oh, okay.
P
So
of x.
fx1 of 3
And fx2 of 3.
Marginal.
2 of
They
3.
should, they should be
But they are
equal.
not equal. Yeah, they should be equal.
they should be equal. Yeah, okay,
Yeah.
okay.
If they are equal, they are identically distributed.
ma'am, just a follow-up question to
Okay,
this,
okay.
ma'am.
Now I
Like there are two terms, independent and identically distributed, right? So
Right.
out of curiosity, I'm asking this. So on total permutation combination, there will be 4 cases: dependent and identically distributed, independent and identically distributed. So are we going to study those cases? Are those cases in practice, or that is a complete hypothetical question?
Can you repeat?
Yeah. See, there are
Yeah.
two types of event. There are two types of event: dependent and independent, right?
Yes.
And let us say identically distributed and non-identically distributed, right? If I make a matrix, so total 4 cases will come into picture.
Okay.
Can you
No,
write
no,
it down,
no.
ma'am?
Okay, I got what you're trying to say. You're trying to say
Yes,
that
yes,
you have
yes.
independent, then you have non-independent,
Dependent,
and then
correct,
identically distributed, not non-identically distributed.
correct.
No, why we are just studying this IID is because it has very useful applications. In general, we can.
Are other cases also exist, or those are only hypothetical cases?
Yeah, like you can say, right? Even you look at this example.
But two hypergeometric example,
Take this example. I had said x1 and x2 are independent, but they're not identically distributed. So you can formulate anything you want. It's not like something
so
that
all
is
four
very
cases,
unusual. Yeah.
all four cases can be formulated, but we are more interested in IID, right?
Yes, all the 4 cases can be formulated. You can
Okay.
cook up any
Thank you.
example and yeah.
Ma'am, I'm
Thank you.
having a query because you just now said that P of 2 should be equal to P of 3 in case of IID, right?
Sorry, P of
2 and P of 3.
no P
Like,
of 3 x.
Yeah. Yeah, x equal to 3 and x equal to 2. The probability should be the same, right?
If provided they are uniform, the probability-
Exactly. Okay. Because I was wondering why it should not be true for binomial in that case. So that's why I was just wondering
Okay,
how
okay.
it is true. So it should not be identical in that case, right? Only the parameter should be the same in case of IID, the type and the
Distribution
parameter.
also should be same.
Yeah, type of distribution and the parameter.
Whatever parameter they take. Yeah.
Okay. Okay. Thanks.
So
Ma'am,
okay.
I have one doubt, ma'am.
I've okay. Before that, I just wanted to know. Okay. So in week 2, you have lecture 2.5 was examples on function of one random variable. So
Yes.
since this is just an example, we can skip
More or
to
less clear, ma'am. Yes,
what?
that is more or less
Yeah,
clear,
Yeah,
ma'am.
examples you
skip
That
can
is more or less clear.
see and
Wow.
just clear it, right?
Just
I think 9, 10, 10 and 11 are more critical.
Ma'am, I want to ask something.
Okay, wait.
Okay, ma'am.
Can you tell me what do you want to ask?
Yes, ma'am. I want to ask in independent and identically distributed IID. And suppose there are n numbers of variables.
Okay.
So should each variables have the same probability?
for uniform, it should be 1. It should be equal.
It should be equal.
If it's a uniform.
Uniform distributed.
Okay, so n random variables we are coming in the last weeks. So I will come to this question again. Okay.
Okay, ma'am. Suppose
Yeah.
there are two or three random variables. Okay. So for independent and identically distributed, all the 3 random variables should have same probability and their marginal probability. And what you can say about the marginal probability? The values which these random variables are taking have the same probability. And what you can say about the marginal probability of all the 3 random variables? Are there individual
marginal probability of 3 random variable?
Yes, ma'am.
So okay.
It should be 1 by 3, right? If it is a uniformly distributed.
1 by 3. All probabilities are same for each variable.
I am asking about the general case.
Yeah,
I haven't told that
Yeah.
it is a uniform or binomial or something else. I'm taking only the 3 random variable. They are identically and independent and identically distributed. And I just want to know individual probability that the random variables are taking should be equal or not.
No, you are talking about the 3 event, or you are talking about the 3 x1, x2, x3, right?
3 random variables.
3 random variables.
Yeah.
They are independent and they are
identically distributed. They are independent and they are identically distributed. Suppose we calculate the marginal probability of all the 3, then will it be equal?
Their individual probability will always be 1. Na? If they are independent random variable,
okay.
the summation of all probabilities. Say for
Will
example,
be equal
x1 is
to
having x1 is having 4 events, right? So the summation of probability.
Suppose
of all
x1 is taking values 0, 1, and 2.
Correct, 0, 1, and 2. Na? So whatever probability you are assigning to 0, 1, and 2, the sum of all 3 probabilities will be equal to 1. Correct.
Okay.
In the same way,
that's why the margin. Look, in independent and identically distributed, the marginal probability of each random variable should be equal.
yes.
That doesn't mean that the individual probability should be equal. Suppose it is taking 0 with the probability 1 by 2.
So
and
it should be equal to for all the like values that a random variable are taking, not for just one.
No, for example, if suppose
then
0, 1,
then we are talking about the marginal probability,
Yes.
See, for example,
not
X1 if you're
about the
taking 1, 2,
individual
3,
for example,
probability
you are
that
taking,
Can,
for example,
not-
you are taking 0,
can
1,
you
2.
please just
it-
yeah.
not about the individual probability that the random variable is taking, just marginal probability. If we add all the probabilities of random variable that X1 is taking,
Margin,
For any,
Sridhar,
I
can you
guess,
can you hold on for some time?
either way,
No,
Sridhar,
I guess,
yeah, just please hold on for some time. Like
I guess for any random variable, marginal sum of
Sridhar, that question that you had just asked about the ID, right?
yes, ma'am.
I will come back to it at the end. Okay, so
Okay,
let's
okay,
not
okay.
extend this topic so far, right?
Okay, ma'am.
Okay.
Thank you.
Yeah,
Okay.
I will come back to it. Just remind me at the end.
Ma'am,
Yes, who's there?
ma'am, Rajesh, ma'am, in our case where you are explaining the marginal, sorry, IIDs.
Yeah, I just said we'll come back to this topic again. Yeah,
Okay.
let's not extend this so much.
And
I will
ma'am,
come back to it.
I also want to say that please discuss one question where we find a function of two random variables by taking geometric distribution.
Function of two random variable. Do you have any example
Yes,
in
ma'am.
mind?
Yes, ma'am. I am looking in practice assignment.
You're looking at practice assignment. Okay.
Ma'am, question number 6.
Just give me a minute. Okay, so what is the question? X1 and X5 be IID geometric way. This one?
Yes, ma'am. Ma'am, and mainly I am getting stuck in graded assignment question. Ma'am, I just want to please discuss the conceptual part, like graded assignment
okay.
question number 3, ma'am.
No, graded assignment question we cannot discuss it here.
Ma'am,
So
please don't discuss question. I just want.
yeah, I will give you the idea. Like you
Yes,
have
ma'am.
the doubt in this concept, right?
Yes, ma'am. I'm unable
So
to
I will just
understand the
write
question.
I will just write the question here so that everybody could see.
Ma'am, are you going to discuss the maximum and minimum function?
Yes, 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 yes.
Ma'am, I can't
I have
see
a lot of
anything.
doubt.
Are you writing?
Okay, after this question, we are going to start the function of random variable where we talk about the sum of random variable, maximum and minimum. Because I know most of you will have doubt from those two topics, right?
Yes, yes.
Ma'am, even I have a doubt in maximum and minimum.
Yes, yes, I know, like most of you will have doubts from
9,
there.
10, 11 are very critical. 9, 10, and 11.
Yes, yes, yes. I
Ma'am, could you
understand.
please discuss those activity questions from maximum and minimum variables, ma'am?
I will not discuss all the activity question, but I will give you an idea.
Yes,
like,
ma'am. I
will
want an
just-
idea because I have a doubt
Yeah.
in one or two where I'm getting confused, like how to go about it. So once you come to that discussion part, I'll just tell my other questions which I want to be discussed, ma'am.
Yes, okay.
Thank you. Ma'am.
So the question
Ma'am?
he asked, yeah.
Ma'am, can we go once through the contuation? Like,
Convolution.
yeah,
Convolution. Yes.
convolution. Yes.
We can go. Yeah. So I will just write down the question that who had asked this question. Practice assignment.
Rajneesh, ma'am.
Rajneesh. Okay. Yes. I will write the question and then we'll discuss what it is there. So this is question number 6 from practice assignment. So it says you have two random variables, X and Y, okay, and they are IID geometric P. All right. So you have two random variables, and since this P is the probability, so it should always lie between 0 to 1. Now, what you have to find here is find the probability that x equals to 6, given that the sum of two random variable x plus y is, let's say, it is 10. It's just a specific example. I mean, you put a value and then maybe you all would have gotten some different values. So what should be the first step here? Anyone would like to?
Yes, ma'am. We can write
You need to find
x equals to
One by one, you can raise
minus
your
y.
hand and I will see.
Ma'am, our first
Yeah.
step should be to find x plus y, the range of x plus y.
Range of x plus y. Okay.
Yes.
So okay.
Before that, we have to find them x and y.
Range of x plus y.
Yeah.
So you're
Yes.
saying first. Okay. So till one. Okay.
Sorry, ma'am.
Who else is there? Yeah. What should be the first step that we should look into? Anybody else?
Union of x plus
Yeah,
y
I think
and x equal to 6.
Sorry?
The intersection of x equal to 6 and x plus y equal to 10.
Intersection. Okay.
Madam, I have a question here, not the answer itself. When we say probability of x is equal to 6 conditioned upon x plus y is equal to 10, does it imply that y is equal to 4?
yes, ma'am, same question, because we can find x equal to 6 and y is equal to 4.
Yes.
Yes.
If
Yes,
that is
ma'am.
y is equal to 4,
Yes.
then probability of x intersection 6,
Then
y
we
can
intersection 4
simply-
X is
divided by
equal to 6
See,
and y is equal to
please
4.
speak one by once. See, your x is geometric p, right? So if you have a random variable x, right, and I'm saying this is a geometric p distribution. So what is the range of values that your geometric random variable takes?
geometric is 0 to 1.
0 to 1.
0 to 1.
1 to infinity, right?
1 to infinity.
1 to infinity.
1 to infinity.
1 to infinity. This
Yeah.
is not the range
Yes,
of
ma'am.
a geometric distribution. The
No.
range of geometric distribution that we have studied is from 1 to infinity. So either you will get the, what does it mean? It means either you will get the first success on the first trial, or you'll get the first success in the second trial, and so on, right? Similarly, I have said that y is also a geometric distribution, right? So if y is also geometric distribution, again, it will also take values
1 to infinity.
1 to infinity. Now I have defined another random variable, let's say z, and this is given by x plus y, where x and y are independent, right? So let's say if I draw a table here, I'm drawing a table here. So x is taking 1, 2, 3, it can go to infinity. 1, 2, 3 can go to infinity. So I will just write the sum here. So if you do 1 plus 1, right? I shouldn't have it like this. So okay, this is x, this is y. You have 1. So with 1 you can have 1 as y, 2 y equals 2, y equals 3. You can have y as infinity, right?
Yes, ma'am.
So if you sum it over, so like if one of the random variables, if x is 1, and if I say z equals x plus y, and I want sum to be 10, fine. I want x plus y to be 10.
It should be 9, y equal to 9.
9.
And if I am taking x to be 1, y can only be 9. Okay?
Yes.
Yeah. Yes, ma'am.
So if x plus y equals 10, and it is given that x plus y equal 10, then and x equals 6, then it should be y should be equal to 4, right?
Yes.
Yes, ma'am.
Yes.
So if x to be 6, then y should be equal to 4. And since it is a conditional probability, I can write this as what is the formula of conditional probability?
Joined by marginal.
Joined by marginal.
Joined by marginal.
So this you will write this as probability that x equals 6, comma, x plus y equals 10 divided by probability that x plus y equals 10,
10.
right?
Ma'am, as they
Sorry?
are independent, ma'am, probability multiply x. X
Yeah,
equals to
so
6 and y is equals to 4.
see, if I am writing x equal to 6 and x plus y equal to 10, so the basically we are asking about the probability of occurrence of these two events, right? And so it will happen only if x is 6, your y should be 4.
4.
Right? So x equal to 6 and y equals 4 divided by probability x plus y equals to 10.
Yeah.
Now we know that x and y are independent. We can separate it out. Fine. So we'll just look at the numerator part first. So since x and y are independent, we can always write this as probability x equal to 6, probability y equals 4. So this part is clear, right?
Yes.
Now how will we solve this?
And just apply the formula of geometry.
Yes. Apply the formula for the geometric. We know that x takes the value from 1 to infinity, y takes the value from 1 to infinity.
Yeah.
And if x and y are geometric, then its probability distribution is given by
1
1 minus
k
p
minus
to the
1
power k minus
1
into
minus p to the power k minus 1 into p,
into p.
which
Yes,
is
ma'am.
equal to probability x equal k.
K. Yes, ma'am.
So we can just substitute it here. So numerator part is done. Now we have denominator part. So in the denominator, we have probability x plus y equals to 10.
So we have to find all the possibilities. X equal to
We
1.
have, yes. Then in
Ma'am,
this case,
I have a direct formula for this.
yeah.
Please
Ma'am,
share.
Yeah, please, sir.
Ma'am, p
Yeah.
square into p1 minus p to the power n minus 2 into n
Okay.
minus 1.
Okay, I will write it here. Can you repeat again?
Ma'am, p square
P square. Wait.
into
In minus 1.
1 minus
Just
p.
wait.
Just a
Try
second.
to write. Wait. I will share it again. Just give me a minute. Okay. Second here. Okay, we'll do it. So probability x plus y
Yes, ma'am.
equals to 10, right?
Yes, ma'am.
Yeah, somebody was telling me the formula.
P square
P square
into 1 minus p to the power
1
n minus 2.
to the power n minus 2.
Yes, ma'am.
Okay.
1 minus p to the power n minus 2 only.
1 minus p to the power n minus 2. Okay.
Into n minus 1.
Into n minus 1. There.
Yes, ma'am. Yes, ma'am.
And what is this thing?
Ma'am, this is the ma'am. We can also drive it from the ma'am as
No,
they
no,
are
no.
independent.
What is this? What is this that thing
Ma'am,
that you
this
have
is
to
the
write?
ma'am. This is the sum of probabilities of all the conditions that x plus y is equals to 10.
X plus y equals to 10. You are saying.
And this is the sum of all the probabilities that x plus y is equals to 10.
Okay. Can you derive it?
Yes, ma'am. We can also derive it from ma'am as ma'am we are taking the summation of f of x into f of y minus f of y of z minus x. So ma'am, from that we can also derive it that the formula is that.
Okay. I hope if you know this, you know how to do it.
Ma'am, we can also find it on Google, ma'am.
It's the correct one.
Your x plus y equals 10.
Yeah, no,
No, I
I'm
think-
just saying if you know how to derive it, it's a good thing.
Yeah,
But let's not look at the formula. let's try to just go about like how will you solve it? Okay. So what we have to find is that probability of x plus y equals to 10. And we know that x and y are geometric distribution. So x takes the value between 1 to infinity and y take the value between 1 to infinity. So in this case, your x and y can have multiple values. If x is 1, y can have 9. If x is 2, y can have 8. X is 3, y can have 7. So it will go on. Similarly, if x is 1, y is 1, x can be 9. So you have many cases here. So what will I do is, like I will, let's say I'm fixing my x to be some I, okay? And this I should be less than 10.
Yeah.
Right? Why it should be less than 10? Anybody?
Because y cannot be 0.
Range is from 1 to infinity.
Range is from, yes, because range is from 1 to infinity. So what we'll say is I should be less than 10.
10.
And if x is I, then our y should be
10 minus
10
I.
minus I, right? And we will sum it over. So since I should be less than 10, so I will vary from 1 to 9. This is clear?
Ma'am, it will be less than or equal to also 10.
No, not equal to. That's what I had asked. Why not equal to? Can you think about it? What will happen if I becomes 10?
When I equal to 10,
No,
then
no,
it will
please
be
be-
x
please
equal to
be-
0, na?
Let him think. Yeah.
That is not
Yeah. So if I becomes 10, your y
Y will
becomes
be
0.
0. Yes.
That is not possible because y is a
Okay.
geometric random
Okay.
variable.
Okay. Ma'am. Yeah.
Right?
Thank you.
So now we have reached till here. Now what we can do? How will we go further?
So I
Anyone?
think
One by one. So okay, I will ask. Ranjish, can you tell me what should we do?
I'm not sure, ma'am.
You're not sure? Okay. Manan, can you tell me what should we do here after this?
Ma'am, we can
Hmm?
take the intersection. Oh, sorry, it is a summation, right? We will have to.
You're right.
Sum up the intersection means probabilities of x equals to I and y equals to for all the probability for all the possibilities which we have taken.
I
That-
think
that
X
we have
and Y
already-
are
Okay.
X and Y are independent.
Okay,
X and Y are
Sridhar, Adit, you please go on.
Ma'am, I think it's a joint probability and we will just find the joint probability of x and y.
This is a joint probability and we will find the joint probability of x and y. But how will you find the joint probability of x and y?
Ma'am, by convolution.
By convolution. Okay. So, like what do you mean by convolution? If you say convolution?
Like we can write sum of I equals to 1 to 9 and fx fx of x into fy of 10 minus I.
Okay, so you are saying me to write this as sum over fxy. You want me to write this as I and this is 10 minus I. And I
Yes,
is
sir.
varying from 1 to 9. But do we know fx of y?
Can I say something, ma'am?
Yes, Sridhar.
Ma'am, first of all, X and Y are independent.
Yes.
So we can write it as a marginal
We
probability.
can, yes, since x and y are independent,
Yes,
we
ma'am.
can directly write it as product of marginal.
Marginals.
Right?
Yes, ma'am.
Since we did not know what is the joint distribution of xy here.
And
So
then
this is right. This is the same thing. This is right. But what we'll do after this, we don't know. We know that x and y are independent, so we can use it. So after this, we will just say that I is varying from 1 to 9. And this is probability x equal I, probability y equals 10 minus
10 minus I. Yes, ma'am.
then we will apply the formula of geometric.
Yes,
Yes,
we can directly apply the formula for the geometric distribution, and we can
we can
complete
do
this.
some adjustment.
So if I ask, okay, I'll ask somebody. So what will the probability of x equal I? Ravi, can you tell me?
Sorry, once again, please. Probability of
X equal I.
X is equal to I is going to be P into 1 minus P power I minus 1.
P into 1 minus P.
Power I minus 1.
I minus 1.
Into P into 1 minus P power 10 minus I minus 1.
Such a big expression, okay?
No, I was telling the probability for Y is equal to 10 minus I as well.
Okay. All right. So fine. This is
Gotcha.
right.
This
And
is
probability y equals 10 minus I. So this is going to be
P
1
into
minus P to the power
10
minus I minus 1 into P.
P.
Right? Yeah. So we can just substitute it and then do the summation and we can get the value.
Yeah.
And can't we do some adjustment so that we can reach to some conclusion?
What adjustment? Can you tell me?
Anything first to, can you multiply both and
Okay, so if you multiply both, what we will get? We will get P square
1 minus
times
P.
1 minus P. So I minus 1 minus I will get cancelled out.
It will
And we will
become
be left with just
8.
8.
8.
Right?
8.
Yeah.
This is the
So
formula
this-
he has. This is the formula he has said. Yeah, the same formula.
This is what
0
we
to
got.
9, madam. 0 to 9, madam.
0 to 9.
Not 0 to 9.
Sorry, I is equal to 1 to 9.
1
1 to
1 to 9.
1 to 9.
Yeah.
And when we sum it up, because there is no more I involved,
Yes.
summation of I is equal to 1 to
It
9
is
will yield.
just going to be 9p square 1 minus p to the power 8.
yes,
Okay.
Right?
All right. Thank you.
and we got it.
So Rajneesh had asked this question. Is this question clear, Rajneesh?
Yes, ma'am.
Yes. Okay. So the doubt that you had from the graded assignment, is it clear?
Ma'am,
Yes,
in that
ma'am.
question,
I
P was
was-
varying. Sorry. In that question, P was varying from 0 to 1. So
Yeah.
we can, for P, what value should we take?
P. Why do you need?
I mean, it was in the
P?
range in the 0, comma 1.
That will be given in the
It
question,
depends
yeah.
on the what P value is provided in the question.
It is 0, comma 1. Closed
No,
interval.
it is 0, comma 1. It says P belongs to 0, comma 1.
Yeah.
What does
yeah.
it mean? It means P can take any value between
Any
0
value.
to 1.
Yeah.
It
yeah,
can be any
yeah.
value. It can be 0.11, it can be 0.5, it can be 0.5. It can take any value between 0 to 1. What is this
Okay.
P? This is the probability. So we know that the probability always lie between 0 to 1.
Yes.
Right? So it can take any value. It depends on what value of P do you have in the problem.
Okay.
Okay.
But in the practice assignment,
But in fact,
it's given just
Yeah.
P and
But
we
in
are
the
asked
problem, it
to
is not given.
we are
yeah,
asked to write up to
Speak
zero
one by.
decimal.
Don't speak together.
Okay. Ma'am,
Alex, yeah, please.
yeah.
Joseph.
So, in the practice assignment, it is given that the probability is just P and is included in the
Yeah, that
closed
was
interval 0 to 1.
I was saying.
And we are told to write up to 2 decimal places accuracy.
It
Oh,
gets
that-
cancelled out in that problem actually if you solve it completely. The P
Okay.
will get cancelled and you'll remain with just the decimal part of it.
Will it?
Because you did not
Okay,
solve the numerator part. This is just the denominator part.
Okay. Okay.
Yeah, yeah.
If you write both of it together, the terms will get cancelled out.
Numerator part is p square into 1 minus p whole raised to 8 divided by 9p square 1 minus p
So
raised
you
to 8.
just have
So
1
those
by
cancels. 1 by 9
by
is the
9,
answer for
okay.
that.
Yes.
Okay.
So you got the answer here.
Yeah.
1 by 9. Okay. Nice.
Very nice explanation.
Nice
Thank you.
question. Thank you.
Yeah, thank you. So
Ma'am,
yeah,
one thing,
somebody.
if x plus y equal to 10 is given, okay.
Huh.
So if it is a x plus y less than equal to 10 or something like that, so we have to go through all the process and have to do it, right?
You will have to sum it. Right. Okay, so I will try to go back to the same screen. So somebody has asked that previous one was more clear for writing.
Yeah.
Yeah, so wait, it was not working there. Just give me a minute. Yeah, now it's working. I will share the screen. Yeah.
Hello.
Yes,
Ma'am?
yes.
Ma'am, on the last class, you told that we will discuss meteor problem.
Okay, yes.
Please
That
discuss
we
the
left.
maximum minimum function.
Meteorite problem. Okay, just let me write it somewhere. I can go back to there again. So, meteorite problem.
Which problem is this?
This is from week 0. We were discussing in the last class. So yeah,
Please
this was
take this
something that
question
was
at the
left.
end, ma'am.
Yeah, I will take it at the end.
Yeah.
It's fine. Like, let's not break the flow here.
Yes,
so we'll start from maximum and minimum. So I hope this is something where you all are facing issues.
Yes.
So, okay. Let's first start with 2 random variables, okay?
Yeah. Hello.
So you have maximum and minimum of 2 random variables. Okay. So let's say we have x and y, and they are jointly distributed. They have some joint distribution of x, y, and we have defined another random variable here that is given by, let's say, z1, and this is minimum of x comma y. Okay, so please mute yourself. Yes, sir. So I'm saying you have a z1 random variable that is defined as minimum of x comma y. So what do we mean by that? Let's say, let's take some very basic example. So you have a random variable x, you have a random variable y, and x is taking the value, let's say 0 comma 1, and y is taking the value, let's say 1 comma 2. Okay. So I will write their joint distribution. Let's say this is 1 upon 2, this is 1 upon 4, 1 upon 8, 1 upon 8. Okay. So all this sum up to 1. Now, instead of writing this, if I write it like x is there, y is, you have y, and you have z1. Okay, so z1 is minimum of xy, and on this side I will just write the probability distribution of xy, joint distribution of xy. So x is taking just 2 values, 0 and 1, right? So 0 and 1. So if x is taking the value 0, y can take the value 1, and y can take the value also 2, right? And if x is taking the value 1, y can take the value 1, and y can also take the value 2. So you have total 4 possibilities. We know these probability. 0 for 0 comma 1, you have 1 by 2. 1 comma 1, you have 1 by 4. 0 comma 2, you have 1 by 8. and this you have 1 by 8. Now, if I have defined Z1 to be minimum of xy, so look at this first row here. Right? So, which is minimum between 0 and
0.
1? It is 0. What is minimum here? 1 comma 1?
1.
1. What is minimum here? 0 comma 2? 0.
0.
1.
In this case, it is 1. Right? So, what all the possible values your Z1 is taking?
0 and 1.
0 and 1.
Z1 is just taking 0 and 1. And what is the probability that your Z1 is taking the value 0?
1 by
2. 1 by 2.
1 by 2.
1 by 2 plus 1
1
by
by
8.
2.
Okay, somebody
1
said
by
it is
2.
1 by 2, 1 by 2 plus 1 by 8. Which one is right?
1 by 2 plus
1 by 2.
1 by 2.
1 by 2
1 by
plus
2
1 by
plus
8.
1 by 8, ma'am.
1 by 2 plus
1 by 2
1 by
plus 1 by
8.
8.
Right?
Yes, ma'am.
Why, ma'am?
Huh.
2 by 4,
So,
ma'am.
0 taking 2 times.
yes. So, you have Z1 taking the value 0 with it is happening
Okay,
when
okay.
x is 0 and y is 1. It is
Yeah,
also
got it.
happening when, so you'll have to add, right? So
Okay.
what is this? This is going to be 5 upon 8, right? And this is going to be 3 upon 8.
3 upon 8.
This is fine. So we'll say this is the distribution of your Z1, minimum of xy. Okay. Similarly, instead of writing Z1, I'm defining another random variable Z2 that is maximum of xy, right? Let's make another table here, column here, and I will write this is Z2. So what all the values Z2 can take? So in the first case, it will take 1. Second, again 1. Third, again 2. And here also again 2. So what all values your Z2 is taking?
1, 2.
1, 2.
1 comma 2, right? So what is the probability that Z2 is taking the value 1?
And Z2 is max, right?
2 is maximum, yes.
3 by 4, ma'am. 1 is
3 by 4, right? So this is 3 by 4 and this is 1 by 4.
1 by
This
4.
part, is this part clear to everybody? Can you raise your hand?
Ma'am, can you please 3 by 4 calculate?
Yes.
How it
So you got it, or you still want?
No, I am not getting it.
Okay. So Z2 is defined as maximum of xy. This is maximum of xy. Fine. So if I'm saying Z2 is taking the value 1, so when is Z2 taking the value 1?
At 0, 1 and 1, 1.
0, 1,
1 and 1, 1.
0, 1 and 1, 1, right? So what are the probabilities of this?
1 by 2 and 1 by 4. Yeah.
1 by 2 and 1 by 4. So you will have to add those probabilities, right?
Okay. Sure.
And for 2, similarly, you have
Similarly.
these 2 cases.
Yeah.
Right? So this is your distribution of Z1 and Z2. Now we'll come back to the theory part. So if I have defined our Z to be minimum of xy, okay. If I have defined my Z to be minimum of xy, then what is the PDF or PMF? So we are talking about discrete random variable here. So x and y are discrete here. We are not going to continue. So you have PMF, okay. So if x and y are random variable and minimum of xy is a function of random variable, correct? Z is a function of random variable. So Z basically is also a random variable. So if Z is a random variable, we can find its probability distribution. So if I have to find the PMF of Z, so we can write this as probability. So what is this going to be? Can anyone tell me? What is F?
Minimum of x comma y.
Minimum of x comma y.
In summing all the probabilities.
Z1 is minimum, right?
Minimum of x comma y. Yeah, let's write it Z1. Yeah.
Equals to Z, ma'am.
Equals to Z. Correct.
And then summing all the probabilities, ma'am.
The maximum of z, say x.
No, what I have written here is you have a random variable z1 that is defined as minimum of xy. Correct?
Ma'am, in
And
in LHS, what you have written? F of Z1, then in bracket.
this is your z here.
Okay.
Write it properly. Okay.
Yeah. Okay.
So this we can write it as probability that minimum of xy is taking the value z.
Yes.
Correct?
Yes.
Yeah.
Now, once minimum of xy is taking the value z, what can we write after this? You have two random variable x and y, and we have z, z1 that is minimum of x comma y. So if minimum of two random variable is some small z, so what all possibilities you can have?
X greater than equal to z, y greater than
X greater than equal to z, y greater than equal to z. Okay,
And both are equal.
Both are equal. What do you mean by x greater than z and y greater than z?
like any value when you
Ma'am,
can you
when
repeat? Minimum value.
One by one. Okay, Rakesh, can you please tell me?
Suppose 0, 1, we are going for 0. So obviously that is the minimum value I'm looking for, it should be less than we are going for 0.
Okay.
So when you trying to find out the minimum of x, y, z, the value should be above the greater than 0.
It should be greater than 0, right? So
Can I?
Who is there? Rajneesh, is it?
And if we choose x, then then y will be the less than. Sorry, no.
Okay.
Minimum of x and y is equal to
Shajan, you
z.
want to explain?
Yeah, sure. So basically, x is greater than z whenever y is z. Let's say we have fixed y as 1, then x can be anything above 1, the answer will be 1. That should have been the three conditions. One, when y is equals to z, x can be anything above z. And when x is equals to z, y can be anything above z. And there can be another condition, both are equal.
Yes.
So I think these three will sum up the complete scenario.
Yeah, these three will solve the complete scenario, right? So if I'm saying that minimum of two random variable is set, so if I let's say that your x is minimum, okay, so if x is minimum, y can be greater than z, right? Or what we can have is that your y equals z, okay, your y equals z, and your x is greater than z.
Yes.
And one case that you can have is your x is z and y is also z, right? So these are the three possibilities that we can have. So we can just submit all the three cases. So you will have probability x equals z, y greater than z, plus probability x greater than z, y equals z, plus probability x equals z, y equals z. So what can we write this as?
Product of marginals.
Sorry. Can we write it as product of marginal?
Depends if they're independent or not.
Depends
If they're independent. Yes. So if it is given that x and y are independent, we can definitely write it as product p x equals z into y equals greater than z plus this. But here I did not say anything about that x and y are independent. So I will just write that this is going to be the joint distribution of xy, where x is taking the value. So this is going to sum, right? So x is taking the value z, that is fixed. But y can take any value that is greater than z, right? So
Z plus.
Right?
Sorry.
So y can take any value which is greater than z. Similarly here, it is fxy, where y is fixed and x can take any value. Yeah, so this is x, this is your z, and x can take any value which is greater than z. Plus some, this is not some, here we know that both the values are fixed, that is z and z. So it is just fx of y, z comma z. Right? Okay. So I hope this part is clear.
Ma'am, sorry, I didn't get it. Can you please explain one more time that fz1 within bracket z from that part, please?
Which part?
Ma'am, right after the first line you wrote z1 equal to minimum xy. Almost the whole thing.
You did not get this part?
No, ma'am. What are we trying to do here? What is it that we are trying to do?
Okay. So if I say that you have a random variable x, right? And its PMF is given by fx of x. So what is this exactly? If x is a discrete random variable, how will you write this?
Ma'am, fx would be the probability distribution. So unless I know what distribution it's following, how can I write?
No, what does it basically represent? I mean, this is a probability distribution,
Yes.
but what does it represent? You have a random variable capital X that is taking the value small x.
Probability of the different values of capital X the random variable can take.
But here this x is small x is the value that x is taking.
Yeah,
So
particular value.
This I will write it as probability that x is taking the value small x.
Yes.
Right?
Yes.
Now the same thing we have written it over here. Your z1 is a random variable, right? And it is defined as minimum of xy. Correct?
Got it, ma'am.
Huh?
Got it.
So similarly, the way we have written fx of x is probability x equal to x, we are writing probability that z1 is taking some value fixed z. And since z1 is defined as minimum of xy, we are writing probability minimum of xy should be equal to small z. Right?
I'm trying to grasp, ma'am.
Okay. Can you take some time and try to think about it?
Okay, ma'am.
Suppose you are defining there is a 1, 2, 3 random variable. So you want to minimum of xy. Suppose 2. You are finding 2. So the one combination will be 2, 3. Then y should be greater than 2. Then x will be 2. Another option is that
Rakesh, yeah, just I will stop it in between. So
we have an example, ma'am. Can you please?
Ma'am, could you explain that example? Means it will be clear for everyone. That
In activity question, ma'am, we have.
Yeah.
Okay. Question number 6, ma'am.
Activity 2.11.
Yeah, one also actually, ma'am. In the
The first example, if you explain, it will be clear, ma'am.
Activity 2.11.
Yes, ma'am. The first example, if you explain, it will be clear, ma'am, for everyone.
AQ 2.11. Okay.
Ma'am, sir has explained this topic by taking the Cartesian plane. That was more easy.
Cartesian plane.
Means, ma'am,
Okay,
taking
okay.
X and
Yeah,
Y
yeah.
plane.
Yes. Okay, so the example that you have in the first problem here is like the application of what we just have discussed. Okay, so here you have the joint distribution of xy is given. So you have x here, you have y here. X is taking the value 0, 1, 2, 3, and y is taking the value 0, 1, 2. And this probability is 1 upon 12. This is everything is 1 upon 12. Okay, 1 upon 12, 1 upon 12. Everything is 1 upon 12. Now the question says find fz1 of
1.
fz of 1. Okay. So I will just give you a minute to do this. Just do it and let me know what answer you all get. Just take a minute and try to solve it.
Ma'am, what is Z?
Okay, yeah, Z1 is defined as minimum of XY. Okay. Keep yourself muted. Just if you are done, just raise your hand. I will ask your answer. Okay. Yeah, I will ask your what answer you get in a minute. Okay.
Yeah, I'm done now.
So I can see only 5 people raising their hands. 6, 7, 8, 9, 10. So 12 people have raised their hands. So I will ask. Vizi Ayer, can you tell me what answer you got?
I got 1 by 3.
1 by 3. Okay.
And the number of such possibilities are calculating 4 out of 12. That translated to 1 by 3.
Okay,
Taking all the
1 by
values.
3.
Yeah,
Okay.
1, 1.
What about Shabnam? What answer you got?
1 by 3.
1 by 3. Okay.
Yes.
Deependra?
Yeah, same 4 upon 12, 1 by 3.
Okay. Manan, what answer you got?
1 by 3.
Okay,
One.
so everybody got 1 by 3.
Yeah.
Okay. So anybody who wants to know, yeah,
And I got a 1 by 2 and 6 by 12.
you got 1 upon 2. Who is that? Rajneesh. Is it?
Yes, ma'am. May I explain?
You got 1 upon 2. You got, okay, somebody got 1 upon 2, 3 upon 4. Okay. Any other answers apart from these 3?
1 by 2.
Okay, so first I would like to know who got
1 by 4.
1 by 4. Okay. Okay, so I would like to know how did you get 1 upon 2?
Ma'am, may I?
Okay, next.
Who is Rajneesh, right?
Yes, ma'am.
Yeah, please tell me how did you get 1 by 2? I will
Ma'am,
just write it here for
minimum
you.
of x and y should be 1. So
Minimum of xy should be equal to 1, right?
So pairs that give 1 as z equal to 0, 1, 1, 0, 1, 2, 2, 1, 3, 1, and
So you
1.
have taken 0, 1. What are the values?
1, 0,
1, 0,
2, 1,
2, 1,
1, 2,
1, 2, yeah,
3, 1, and 1, 3.
3, 1, and 1, 3.
Okay, ma'am?
Okay, so how did you get 3 here? 1, 3?
Ma'am, minimum of 1 and 3 will be 1.
So your first thing is x, right? You're writing this as x and this as y. First coordinate as x and second
yes,
as y.
yes. I did wrong one. Yeah,
Wrong?
why should not be?
Yes. Okay. What about 3/4? Who got 3/4?
And actually, it's 1/4. By mistake, I said 3/4. There are three cases, man.
Okay.
1, 1, 1, 2, 1, 3.
1, 1, 1,
1,
2.
2, 1, 3. 1, 2, and 1, 3.
Okay.
So 1/12
So,
plus 1/12 plus
okay,
1
so
by
you're saying
12.
3/12.
Correct. So 1/4. Because of calculation.
So what about other cases? If you look over here,
One
even
case is left.
1, 1 is there.
I said 1/1.
Okay, sorry, 1, 1 is there.
1/2 is there.
2, 1. What about 2,
yeah.
1?
Yes, yes.
Even if you have 2, 1,
Minimum is 1.
minimum is 1. Right? So that thing you had left.
Then going by that logic, 3/1 will also fit.
Sorry?
Then going by that logic, 3/1 will also fit. 3/1, 3, 1, 3, 1 will also fit.
Ty is not
3, 1 actually exists and 1, 3 does not exist, right?
Yes, 1, 3 does not exist and 3, 1 is there. Yeah. So you should be a little careful.
Ma'am,
Yeah.
if I remove 1, 3 and add 1, 1, then answer will be 6/12.
If you add 3 here, you're saying.
In first case, ma'am, 1, 3, it should not be there, ma'am.
1,
Ma'am.
3 should not be there, right?
Yes, ma'am. But 1, 1 should be there.
1, 1 should be there, right? Yeah.
Yes. Then FZ will be 6/12.
But how can minimum of 1, 0 can be 0, 1? How can minimum of 1, 0 can be 1? It is 0, right?
Yes, ma'am. Yes.
Right?
Sorry.
Ma'am, I have a small question here. Like 1, 1, how we can say 1 is minimum than 1? It is equal, right?
But here minimum is 1, no? 1, 1. Even if you take
See,
1,
yeah, the minimum is 1.
anyways it is 1.
Yes.
And ma'am, actually, again, also 1, 3, why it is not possible? Because x value, if I take 1 and y value is 3, so I can say 1 is less than y, right? X is less than y. But why?
In this case, y is not taking the value 3. You should like look at what all values your the range of what is the range of x and what is the range of y.
Yeah.
Madam,
Yeah.
if we are done with this, I was having trouble understanding the cumulative distribution function on this one, like problem 3 in the same activity.
So yes. So after that, we are going to CDF part.
Excuse me, ma'am.
Yes.
Ma'am, I have a doubt in this activity question, sir. Question, ma'am. Can we discuss that question?
Which activity? We just have discussed an activity question.
This 2.11 question number 6.
Yeah, we'll come back to it. First, let's see the CDF.
Okay. Okay,
ma'am. What it mean by capital F and
capital F is the CDF. Yeah, we're going to look at what CDF is.
Okay. So ma'am, CDF is in week 2.
CDF you have studied in stats 1.
Stats 1.
Yeah.
Stats 1 you have studied CDF. And even in week 0 you have studied the concept of CDF.
Okay.
Right? Okay. So after this, similarly, what we have done for minimum of 2 random variable, we can do the same for maximum of 2 random variable. So what will change here is, so, okay, can somebody tell me what the change will be? Like if I take, in place of minimum, I will say, this is maximum.
We will just write, we will, first we will change min, like, P probability of mean xy to probability of max xy.
Yeah.
Then then the that symbols like what's relational symbols will be changed to a smaller than to greater than.
Okay, yeah. So this will
I
become
think that's all.
less than z. This will become less than z, and
Yes, ma'am.
that's it. Because we are saying instead of minimum, we are saying we have maximum.
Next time also
Right.
we are supposed to change in third line also.
We are saying just it is maximum. So if the maximum is z, then if say the random variable x is taking the maximum value, then the other random variable should take the value less than z. Right? So it just think about it, and just small change in the equalities. Okay. Now,
Ma'am, can I ask you just one quick thing? What you shown here, this is a formula in case we get, say, values like really 100 and all, this will be of help, right?
What? If the value is?
Say random variable x and y can take values, say 100 values or 500 values.
Yes, they can take.
Then probably this will be, else we can use a table for whatever values that we have been given.
Then table will definitely not work for you.
Or x equals to 100.
Yeah.
Right.
For,
So
like,
for
if
large
you're,
values of x or the random variable, then we need to definitely use this formula.
yes, you need to use the formula.
Okay.
Yeah.
Yeah.
Okay.
Ma'am, let's move to the CDF part.
What is the final answer for F1 Z1, ma'am? 1/3 or 1/2?
1/3.
Thank you.
Yeah. So we have seen the PDF for minimum. We'll look at the CDF of minimum. Okay. CDF of Z1, that is minimum of xy. Now, what do we mean by CDF of a random variable? Okay. So we have a random, let's say if I have a random variable x, and its CDF is defined as fx of x. So what does it mean? So what will you write this as? What
The
basically
probability of x is less than equal to
x less than equal to x, right? And the CDF is a function from real line
to
0, 1. Right?
When we denote it by capital F, right?
Denoted
CDF.
by capital F, right? So x was a random variable. Now our random variable is capital Z1, correct?
Yeah.
So if I have to write f capital Z1 of, let's say, some small z1, so this is going to be probability that this capital Z1 is less than equal to
Small
some
z1.
small z1, and this z1 is nothing but minimum of x comma y, and this should be less than equal to small z1. Okay, so I am saying that our minimum of xy
Ma'am,
is less than, yeah.
Ma'am, please repeat from the first line, please.
Repeat from where?
First line is f of x small x is equal to x less than
So
x.
this is how we define this our CDF of a random variable, right?
Okay.
If you have a random variable x, just if you have confusion in the CDF, just go back to week 0, part 2, I guess. So there you have some topic on CDF.
Which lecture, ma'am?
Okay, not in week 0.
Oh.
You have certain starts 1, some week 7.
Yeah, ma'am.
Week 7, 8. Just go and check this topic. Okay. So basically, how do we define this as, like, if you have a random variable x, so the CDF, that is termed as cumulative distribution function. Okay. So this CDF is given by probability that your random variable x is taking the value less than or equal to x, right? So this was our definition for a CDF. Now, instead of your capital X, your new random variable is capital Z1, right? So if I just substitute our capital X with this capital Z1, we will get probability z1 less than equal to some small z1. Okay, so this particular small z1 is a value that your z1 is taking, capital Z1 is taking. Okay, so capital Z1 is taking a value, let's say small z1, and this is defined as minimum of two random variable x and y. Right? Is this okay?
Ma'am, it will take till z, small z1, right? Capital Z1 will take values till small z1, like
small z1 till small z1.
Yes. Now, if z1 I replace with a value of x and y, so whatever x and y value I will take, that will be always less and equal till z1. It will be there. Right?
So how will you know what values of x and y from here? Like z1 is just a value, so your z1 is this minimum of xy. This is a random variable. Your random variable is taking one particular value. So that particular value, it will take for some x and for some y. But we don't know what is this value. What is this x? What is this y? We don't know. It can be anything.
Yeah.
This is fixed. This small z1 is fixed. Right? Now, okay. So in this, we are also assuming, let's assume that your x and y are independent.
Yeah.
Okay. Your x and y are independent. So if your x and y are independent, we can write so how will you write this as? If the minimum of xy is less than equal to small z1. Okay, so before we look at the minimum, I think it's better you look for the maximum because that's a little easier. So once you do that, this will become more clear. So let's take the same xy, and you have their joint distribution of xy, and x and y are independent. Okay, and I want to find, let's say z2, you have maximum of xy. We want to find fz2 of some small z2, and this is going to take probability that your capital Z2 is less than equal to small z2, and this is nothing but maximum of xy should be less than equal to z2. So one question here is, like, if the maximum of two random variable is less than some particular value, so what can we write? I have two random variable. We have some value that is fixed.
None of
Be
them
the
is greater
maximum,
than
right?
Z2. None of them is greater than Z2.
Sorry, can you repeat?
None of them is greater than Z2. Neither X is greater than Z2 nor Y is greater than Z2.
It should be equal to whatever is maximum, right?
Yes.
Equal and less than.
Less than equal to. So maximum, if maximum of xy is less than equal to z2, so both of them we can write can be less than equal to z2, either x, right?
X or y.
Probability of x less than equal to
z2.
Yes, ma'am. Z2
Or
and
y can also be less than equal to z2.
Yes, ma'am. And they both are independent.
So this is clear. But can we write the same in case of minimum? We have two random variable. Can we write that the minimum is less than z1? Like both x is less than z1 and y is less than equal to z1.
Y can be more than Z1 also.
Ma'am, how it can, because in both cases, one case it is less than and one case it is greater than.
In maximum case, we could easily write that if the maximum value, whatever the maximum of xy is, if this is less than equal to z2, it means both of them are going to be less than equal to z2. We could easily write this. But can we write the same in case of minimum, if I'm saying the
No, ma'am.
minimum of these two random variable is less than some value z1, can both of them be less than equal to z1?
Oh, ma'am. Why can
So
be
if
greater
it
than
is,
Z1 also?
yes, one can be greater
How,
than
ma'am?
z1 also.
Ma'am,
Right?
we can write it as 1 minus p maximum xy greater than equal to z1.
Maximum xy, okay,
Greater than equal to z1.
greater than equal to z1. Okay, I'll come to this.
If she, ma'am, yeah.
How, ma'am? How, ma'am?
No,
I
this is
think it's
not right. This is
I
wrong.
think it's 1 minus minimum of x and y should be greater than z
Yes, it should be minimum, not maximum.
and not equal to, just greater.
Yes, ma'am. Minimum.
Just greater.
Yes,
Because
ma'am,
we are
just
talking
greater.
about discrete
Just
random
greater,
variable.
greater. Yes,
Right?
ma'am. Minimum.
So how did we come to this?
I just visualize it in terms of that Cartesian table. So it will be everything in that corner. Like total it is 1, right? So we
By
need to get
using
something which is,
CDF property, we can actually say that cumulative
I mean,
distribution.
so basically what I'm trying to tell is,
Huh?
let's say there is 2 cross 2 distribution.
Yeah.
So if we try to map it, so we know what is minimum, right? We can see it in that distribution, but it's easier to figure out what is greater than this one, the end values. We just have to subtract it, and whatever remaining will be minimum of x comma y is less than or equals to z2.
In that visualization, we are repeating the same thing, like 3 2 and 2 3 kind of thing. Can we
Yeah.
delete that one? That is my question. That's why I got some doubt in that one.
It's easy to using that Cartesian table, basically 0 1 2 0 1 2, whatever you use right now to solve.
Yeah.
If
Yeah.
we use it, I think it will be easier to visualize.
Yes. So
This
okay.
problem.
Yeah.
That's okay. Visualization part is okay, but
Huh.
on the corner actually it will be repeating. So are we taking it a different this one xy and yx kind of thing? Same 1 by 12 will be there. So or shall we need to delete one?
We're not talking
No.
about that specific example.
Yeah.
Like
That's what.
we are talking about, like, why did we write this as this? I mean, why did we have to write this as this?
Can we explain it like this? That the total area under, say, if we take it as the x-axis as a point, say z1, small z1, the total area would be 1, right? So we can divide that area into two parts. Minimum of xy is less than z1 and greater than z1. The sum would be 1. So accordingly, we can write it.
No, but why did we have to write this as this?
So the thing is, like, it's very hard to solve a minimum of x comma y less than or equals to 1 because it takes a lot of
Yes.
things will come in the picture. It's hard to get everything. This is pretty much easier compared to that.
Yes.
And
Very
the total, I mean, the probability of minimum xy less than z1 plus p minimum xy greater than z1 would be 1.
Because it's the complement of the other.
Yeah.
Yeah,
This.
I mean, that's what I'm saying. Like, if you take
No,
that.
no, this is fine. What I had asked is, like, why did we have to? So Shrizen had just told why, because it is easier to solve using this way. So in case of maximum, like, if we knew that the maximum is less than equal to z2, so if some maximum number is less, if you have some value, let's say our z2 is, let's say your x is taking the value 0 comma 1 and y is taking the value, let's say just 1 comma 2, okay, and I am saying that your z2, the maximum is maximum of xy is less than equal to, let's say, 1, okay. So if I'm saying the maximum of xy is less than equal to 1, then both x and y should take the value less than equal to 1.
Yes.
Right?
Yes.
But if I write minimum, if the minimum is less than 1, so let's say in here, in this case, let's say the minimum, x was taking the minimum, okay, but it is possible, let's say this is your z1, so let's say the minimum was x, but it is possible that your y can take the value greater than z1.
Can be 1 2 also.
Yes.
Sorry.
It can be 1, 2 also, right? It can take maximum value.
It can take,
Mm-hmm.
so,
Yeah.
right? So it is not possible, we cannot write this as like both of the random variable are going to be less than some particular value.
One will be less, one will be more.
It is possible that one is less, another is more, right? So that is why if we write it in this form, if we write this as 1 minus p times minimum of xy, so 1 minus p minimum of x comma y greater than z1, then
here again that probability of minimum xy, no, even again you're calculating, right? Once we get the minimum of xy, then only we will do 1 minus p into minimum of xy, and that is greater than or equal to z1. But the moment when we're writing minimum of xy, again also we are coming into the same situation that we will not be able to find it out.
no, and now your minimum is greater than z1. So whatever the minimum value is, that is only greater than z1. So if the minimum is greater than z1, the other is definitely going to be greater than z1, isn't it?
Can you give an
example?
Yeah. So if let's say your x is the minimum, okay, let's say in the first case your x is minimum, so x is minimum. So if the minimum value is greater than z1, so x was minimum, so if this is greater than z1, so y that was greater than x min is definitely going to be greater than z1.
Can you take a value and in place of?
Okay, so let's take x to be, okay, so just right here x is 2, y is 3, okay, and we are saying this is, or say this is 1 and this is 3, x is 1, y is 3, and we are saying the minimum is
1
greater than 0. Minimum of this is greater than 0. So in this case, minimum was what was 1,
1,
and this is greater than 0. Even in this case, 3 will be greater than 0. So let's take some different example. So minimum of
1 comma 0.
Okay, 1 comma 0. Why 1 comma 0?
Y can take values.
Let's take 1. Let's take 3. Sorry, let's take 2 and let's take 1. This will not work.
Ma'am, you can go for that activity, ma'am.
The
So it
major
will be
reason,
easier for.
Can we keep it at Z1 only?
the major reason,
Just hold on. Just hold on.
Just a second.
One of one.
Just give a minute. Just give a minute.
Yeah.
Yeah.
So
what explanation I had was, ma'am, to go with 1 minus this one is basically in minimum maximum condition we were able to group in x is greater than or equal to z1, y is greater than or equal to z1.
Hello?
In
एक 11 इंच का cheese bus.
Can you mute yourself? Yeah.
Yeah, so basically when we had that maximum function, we could just group everything together in terms of x greater than or equal to z1, y greater than or equal to z1.
Yes.
Less than, sorry. And we could have taken it. But in the case, if we're using directly p of minimum x comma y as less than or equal to z1, we can't group it. But when we do like this, if we put everything together, we can group it easily in the next step. This is the main reason why I took like this.
Yes, Gajan, that is agreeable, but here we are just trying to understand if that is the case, like p of minimum xy also we need to calculate here. Then only we can say 1 minus p of that is equal to z1. So in order to arrive at
I totally agree with you. The thing is like in this, right? So basically, when we are doing this condition, it can grouping is easy here. You can take, see, minimum of x comma 2 is greater than or equal to 2 if you're taking. So basically, you can go 2, 3, 4, 5. all the values of x greater than 2, which is, let's say it's there from 1 to 6. And just considering a situation where random variable x is 1 to 6 and y is 1 to 6. We want to say x comma y is greater than or 2, right? In that case, we can just group everything 2, 3, 4, 5, 6, sorry, 3, 4, 5, 6, 3, 4, 5, 6. Every value of x greater than 3, every value of y greater than 3, whatever we get, that whole bunch, right? That is true for this.
Okay,
But
if that is the case, then 1 minus p is not required now. Then we know.
No, that's what I'm telling you. That is x minimum of x comma y greater than z1. What we need is less than or equal to z1, right? Whatever remaining is less than or equal to z1.
That
So in
is
that way,
easy,
grouping
actually.
is possible.
Yeah, what you explained is easy because greater than means we can take the rest values. So we can calculate the minimum.
Yeah,
of those.
it's easy to group it,
Yeah.
like similar to what we had grouped in case of maximum condition, right? Similarly, the grouping of p of minimum of x comma y greater than z1 is possible. Just that group and subtract it from 1. It's easier, right? If you draw that
it's
Cartesian
easier.
product, it's easier to visualize. That's the
Yes.
main reason why we're going to this. I hope I'm correct.
Yeah. Yes.
Yeah, you are correct.
Yes. Yes.
Yes.
Now.
Ma'am, one question, ma'am. How to remember this many formulas? Is there any way, or you are going to provide me?
You don't have to remember this formula. Like you can always solve these problems. I mean, what
No,
formula will you remember?
like two Poisson's distribution with CDS. So
Yeah.
that a lot of derivation.
Formula will not be given to you. Okay, so we can see a problem on this if you have any doubt.
Ma'am, what about completing these two problems?
Yeah.
Sorry?
No, I have problem, ma'am.
Can you repeat? Hello?
On the activity question assignment itself.
Ma'am, I was saying that like, what about completing the two problems, 3 and 4?
Yes, ma'am. Please explain the question number 3 and 4 of activity 2.11.
Yeah.
Okay.
It will complete the whole, concept of this.
Okay. Question number 3 and question number 4. So,
Which activity, ma'am?
it is 2.11. Okay, so we have to find the CDF of maximum and minimum, and both at the point 1. So fz1 of 1 and fz2 of 1. Okay. So your z1 was defined as minimum of x5 and z2 was defined as maximum of
X and Y.
X and Y. So the table we had, it was this one. Okay.
Ma'am, I calculated Z1 of 1, ma'am.
Okay.
I got 5/6 because the one person was trying to help us. Based upon his understanding, I calculated 2 and 3 are greater than 1. 1 minus p minimum of x comma y is greater than z1. So z1 is what? 1. So 2 and 3 are greater than 1. So the probability of x is 2 is 1 by 12 and 1 by 12. So it is 2 by 12. So 1 minus 2 by 12 is nothing but 10 by 12, which is 5/6.
So
Please explain in detail.
That is fz1 of 1.
fz1 of 1. That is correct.
Ma'am, please explain in stepwise.
Okay. So yeah, z1 is minimum of x5. Okay. So fz1 of z1, sorry, in this case it is 1.
Ma'am, are we
This is
doing
going
number
to be,
4?
sorry.
Are we doing number 4?
This is question number 4. Sorry, question number 4. So this is minimum of xy is equal to 1. Okay. Sorry, less than equal to 1. So can you mute here?
Less than 1, no, ma'am?
Sorry?
It is only greater than Z1. It should be greater than Z.
Greater than Z.
Yes, ma'am. You
It can
explained it.
also be 1, right?
No,
No,
only
ma'am.
it should be greater than Z1. What, ma'am?
No, ma'am is explaining number 4.
Yeah, that's what I have done with the number 4. I got the answer 5/6. That
Can
is
you
2
tell
and
me?
3 is greater than 1.
CDF of mean. CDF of mean first.
Okay, so this we can write it as 1 minus probability that minimum of xy is greater than 1, right?
So greater than 1 means 2 and 3 are the possibilities.
Greater than 1 is 2 and 3 are the possibilities. Yeah.
Yes, ma'am. So probability x is equal to 2 is 1/12 and probability x is 3 is 1/12. So adding those, it is 2/12. 1 minus 2/12 is 10/12, which
So
is
that is
5/6.
5/6.
No, we should consider both, right? 2,
Yeah,
1 and 2,
1/12.
2, 1, 3, all the 4
No,
conditions which is
only 2
available.
are the possibilities, right? 2 and 3 are greater than 1, right?
Yeah, that's what. The x variable can be 2, 3. And
Yeah.
similarly, y has 1 and 2, right? So it's a combination. So 4 different combinations are possible in that corner. Basically 2, 1, 2, 2, 3, 1, 3, 2.
It is the
All of
minimum,
them.
right? Minimum of x comma y it is.
Yes, that's what.
Hmm.
Minimum
Oh,
of x
3
comma y
and
should be
1
great.
are also.
Yeah, everything,
Yeah.
all 4 are possible. That's what I tried to tell. Everything x greater than 1
Yeah.
and everything y greater than 1. All of them you can group. That's the main reason we went for this.
Oh.
So
then
y greater than 1 means then
8/12.
1 will not come again, right? X value
Yeah, I
when
mean, you can form a group of them here. Basically, what you see here, minimum of x comma y is greater than 1, which is nothing but if you consider x 2 and 3, y 1 and 2. All 4 of them are forming that group. You can see that 4 circles in the corner, right? That
Yeah,
is
yeah.
those 4 of them.
Yeah,
Yeah, that 4 of them, you just remove them from rest of them. The rest everything is that CDF, whatever is remaining in that sheet will form a CDF. That's what nothing but 1 minus 4/12.
Yeah, it's 8/12.
Yeah.
Is it clear to everybody?
But ma'am, the answer given in there is 5/6. We are getting 2/3. So how it is possible, ma'am?
Ma'am, can you please solve
What
that?
is the answer given? Just
The
let me
answer
check.
given is 5/6, ma'am.
The
But
answer
we
given
are
is
getting
5/6.
8/12 is 2/3. So how is it
Z1
possible?
is defined as minimum only, right?
Yes, ma'am. It is defined as
Z1.
minimum.
Yeah, Z1 is minimum of xy. Okay. Answer is given as 5/6.
Yes, ma'am.
So this is fine. Right. So minimum of xy is greater than 1. It means if the minimum is greater than 1, it means x should be greater than 1 and y should be greater than 1.
Yeah.
Right? And it is given to is it given to us that they are independent? Okay, let's not worry about that. So x greater than 1.
X, Y independent.
It's actually given that it's independent.
Okay.
They are independent.
Okay. So x greater than 1 and y greater than 1. Okay. So it can take many possible values. So it can be x2 and okay. So since they are independent, we can write it as probability x greater than 1, probability y greater than 1. So what are values that x can take here?
2 and 3.
X can take 2 and 3. What are values y can take? Just 2.
2. Yes, ma'am.
Right. So x greater than 1, that is x is taking the value 2 and x is taking the value 3. So if you add this,
2 by 12.
You will get 2 by 12.
Yeah, it's 1 by 12 plus 1 by 12.
So it is 3 by 12 plus 3 by 12, 8, 6 by 12, 1 by 2. 1 by 2 into probability y greater than 1. It means probability y equals to 2. This is 1 by 3. Right? And 1 minus 1 upon 2 into 1.3.
Ma'am, how it is?
My bad, I
Could
was
you
wrong
please
back then.
explain, ma'am, once again that 1 by 2 and 1 by 3?
See,
We can
x
look
greater
like this
than
also.
1, x greater than 1, okay? So x greater than 1 means x can take the value 2 comma 3.
Yes, ma'am.
Right? Y greater than 1 means y can take the value only 2.
Yes, ma'am.
So what is the probability that your x is taking the value 2 comma 3? So probability x equal to 2 is 3 by 12 and probability that x equal to 3 is again 3 by 12. So
Yeah,
3 by 12 plus 3 by 12 is 6 by 12. That is 1 by 2. Right?
Correct, ma'am.
This is 1
3
by
by
2.
12, it is
Now,
1 by 12. 1 by 12 plus 1 by 12, it will be 2 by 12 and 1 by 6, right?
no, what is probability x equal to 2?
Or
3
1
by
by
12.
12.
Why is it 1 by 12? This is, everything is 1 by 12, no? This is
2
1
by
by
12. I think he meant 2 by 12, ma'am. The last two, 2 comma 2 and 2 comma 3.
Last 2 comma 2.
Yes, ma'am. We can circle out those
Last two,
Yes, ma'am.
Okay, okay.
Last two, yeah. That.
Yes.
Basically,
Yes.
those are the only possible remaining
Yes, ma'am.
for x greater than x comma y greater than 1, right?
Yes,
Yeah.
yes. So x greater than 1, y greater than 1. You
Yeah.
have these two only the possible cases.
Yeah,
Yes, ma'am.
1 minus
Right.
2 by 12.
So
which
this
is
is
nothing
going
but
to be
5 by
2
6.
by 12. Yes.
1 minus 2 by 12 is 5 by
Total
6.
4 by 12?
Total 4 by 12. Which one is 4 by 12?
No.
These
It's 2
4
by 12.
possible cases.
No, this, okay,
Then
I'll
how-
just clear it.
Ma'am, 2
something.
by 12 we got, no? Then how? But you got 1 by
Wait.
2 there. I just.
Oh, wait. I'll just write it properly. So everything is 1 by 12 here. Okay, so this was the table that was given to you. Now, this is x greater than 1, comma y greater than 1. So x should also be greater than 1. So x can take the value 2 and 3. Okay.
Yes.
And y greater than 1, it means y can take the value only 2. So if you combine it, like only these two cells, that x is taking the value 2, y is taking the value 2, and x is taking the value 3 and y is taking the value 2. These are the only possibilities here.
Yes, ma'am.
So what is the probability if you add this? So this is going to be 2 by 12.
Yes.
Right? This is 2 by 12. So 1 minus 2 by 12 is going to be 5.6.
10 by 12.
By 12.
10 by 12, that is 5 by 6. So 5 by 6 is your answer. Right? Is it clear?
Yes,
So,
ma'am.
ma'am, I just have one small doubt in this.
Okay.
And so, if we try and add directly the below row and the 2-3 columns, suppose if we miss that these are independent, so we'll count basically 1, 2, 3, 4, 5, 6, 7, 8, 8 by 12. But whereas if we take them as independent, then we'll count for x greater than 1 as 6 of those, and for y greater than 1, 4 of those. So, ma'am, this is also like important for us to not miss this independence, or maybe there's a better way. I don't know.
Yeah, if it is given that they are independent, then definitely from there you can, even if it was not given as independent, you could have figured it out. But let's say the table is so big and like you cannot even draw the table, then in that case, if it is given that X and Y are independent, you can use this property. And if you know what is the distribution of X and Y, then it is easier to calculate.
Madam,
The
I
problem,
think,
Thank you.
Madam,
Yeah.
I think
on
the
the
problem
same note,
comes.
if you can actually solve problem 6, that's exactly where this is, and I'm trying that, and I'm not getting the right answer. Problem
Okay.
6 is exactly the same thing as what you just explained, but the generic form, like if there are 10 of them, then how to go about with it?
It's the same assignment.
Same assignment. 2.11, problem 6.
Okay, so you have 10 IID binomial random variable. Z1 is maximum, Z2 is minimum, and you have to calculate if Z2 of 2. So Z2 is minimum. Okay. So it
Yeah.
is given that you have x1 to x10 IID binomial. What is n?
Sorry?
6.5.
Okay, n is 6 comma 1 by 2.
6 comma 1 by 2, yeah.
So 6 comma 1 by 2. Now it is what you have to find is fz2 of 2, right?
Yes.
You have to find fz2 of 2. Yes. So z2 is defined as minimum of x1 to x10. Right? So fz2 of 2, this is going to be probability that minimum of x1 to x10 is less than equal to 2. And this we are going to write it as 1 minus probability minimum of x1 to x10 is greater than 2. Right? So since all the xi's are independent, so we can write like since the minimum is greater than 2, each of the term are going to be greater than 2, right? So we can write x1 greater than 2, x2 greater than 2, up to x10 greater than 2, correct? So since these are independent, we can just separate it out, like we can do the product here, right? And we know that each of the xi's are binomial 6 comma 1 by 2. So once you know what is the distribution of each of the random variable, we can easily find their probabilities, right?
Right.
So yeah, so is there any doubt in there?
Yeah, now it is clear. I was making a mistake. I mean,
So, ma'am, in this we have to know the probability of each variable,
Ma'am, can
right?
you?
Yeah, we can find it using binomial.
We can find it using binomial.
Yeah, probability of x greater than 2 upon 10.
Yeah, and since each of the random variable are IID, x1 to x10 are
Yes,
IID, we can also
yes,
write this as probability xi greater
Greater
than
than
2 to the power 10.
10. Yes, ma'am.
10.
Right? And you can just solve this to the part, you do to the part 1.
Yes,
1
ma'am.
minus. So this is going to be a final answer.
3 plus 4 plus 5 plus 6.
You can calculate.
3, 4, 5,
Yeah.
6.
Yes, ma'am.
Right?
Okay.
Yes, ma'am.
Okay.
And we are multiplying these probabilities, right?
We are multiplying these probabilities.
Okay. That's why it's power 10.
Yes. Because the minimum is greater than 2. So if the minimum is greater than 2, each of the random variable are going to be greater than 2.
Yes, ma'am. There are 10 random variables.
And each of them would give the same value because they're binomially distributed with the same parameters.
Same parameters.
So would we have to calculate this whole thing?
You just have to calculate probability xi greater than 2. So what you can do is, instead of finding probability x1 equal like xi equal 3 plus 1 minus you can do 1 minus probability x equals 0 1 2. You can find and do the part n.
Yeah, that's easier.
That's easier.
Ma'am, can you solve this, please?
ahead.
Okay. What doubt do you have after this? Can you tell me?
I can help you solving this because I have solved it just now.
Yeah.
Okay, please go on.
Yes.
Okay, can you post it in the chat
Yeah,
then?
you post it on the chat box.
Okay,
We will
okay.
have a look.
I can't post it, ma'am. You if you write there, I can give you the exact.
You will tell to ma'am. Okay.
Yeah. So you can skip the calculation part.
Okay, so maximum and minimum is clear, like how to solve the problems.
Yes.
Yeah. Can we try practice assignment problem 3, madam? That is a little.
Practice assignment problem 3. Okay. So there you have two random variable x and y that is defined as number of cars and number of bikes reaching a street corner during a certain 15-minute time period. Okay. Your joint distribution is given and you have to select the options. Okay, so this is just basic calculation.
Okay.
So you have two random variable xy and their joint distribution is given to you as 9/16 4 to the power x plus y, right? And what do you have to find there? You have to find marginal of x. You have to find
Ma'am, which question is
marginal of
this?
y. This is from practice assignment question number 2.
Question number 2.
3.
Question number 3.
Yeah.
So practice assignment question number 3. Like if you have tried to solve it and you have any doubt, you can ask me. Otherwise, it's just basic calculation.
Practice assignment answers are uploaded.
Answers are uploaded.
Answers
you can
are
check.
uploaded.
Okay.
Yes.
Any other doubt from activity problems or any topic?
Activity 211, problem 7, madam. That was with. That was with geometric distribution, and having z as minimum of x comma y.
It is based on the formula.
So this problem has already been done in the like the lecture.
Oh, was
There's
it?
a direct formula for that actually.
Is there any direct formula?
Yeah, 1 minus bracket of 1 minus P1 into bracket 1 minus P2. You can use that formula, you'll get the answer for that. So it is basically 1 minus bracket of 1 minus 1 by 6 into 1 minus, wait 1 second, let me see.
So you can just go back to the lecture, the last
Yeah,
lecture. In the
1 minus 5 by
last
6.
part, this has been discussed.
Okay.
If you have seen it,
211 lecture, is it? Lecture 211.
2.11. Just go back and just check it once again.
Yeah, ma'am, there is a direct formula for that. No, ma'am, the sir has given the formula for that. So it is 1 minus bracket of 1 minus P1.
Yeah, that's what this is what I'm saying. Like it is there in the lecture. So
yeah,
you can just
2.11.
You get
just
Z
because
geometric
it is not easy to remember the formula. It's better you know how the method is. Like how do you solve the problem?
Yeah, the answer is Z geometric 31 by 36. If you do that, you'll get.
Okay.
Ma'am, I have a small conceptual doubt about the marginal probability. Could you please give a glance on that?
Sorry?
Marginal probability, the conceptual probability, because I'm getting confused always with the marginal one.
Okay, so in case of marginal, let's take a basic example from the table. First, understand this. So you have a random variable x and y, okay?
Yes, ma'am.
And x is taking the value, let's say 0 and 1.
Yes.
And y is taking the value 0 and 1. Okay. They have some probability. Let's say this is 1 by 4. Let's say everything is 1 by 4. Okay.
Yes, ma'am.
Now, marginal probability, right? So I will add all the columns. So let's say I will add this column. And what is the probability that you will get? I will add this first column, the probabilities.
1 by 2.
1 by 2. I will add this column. What will I get?
Again 1 by 2.
1 by 2. Now I will add this row here. What
Again
will I
1
get?
by 2.
Again
Same
1 by 2, and here also 1 by 2, right?
Yes.
So you add this like this row and you add this column, you will get 1.
Yes.
Right? So basically the value that you obtain on the margins, right? So these are the margins, I would say. So the value that you obtain on the margins, they are the marginal probability. So how do you represent it as? This probability that you have obtained here, 1 by 2. So this basically is you have done 1 by 4 plus 1 by 4. And this is nothing but this is fxy of 0 comma 0, and this is fxy of 0 comma 1. Okay.
Okay.
Right. So this is what is fixed here. Like your x equals 0 is fixed.
Yes.
In both the cases, you see you have fixed your 0 and you're varying your y. In first case, your y is 0, and in the second case, your y is 1. So this we can write it as sum of fxy 0 comma y, where y is varying from 0 to 1. Right? So if I will add one more, let's say if I had one more column here, let's say y was taking the value 0, 1, 2, and the probability is, let's say, also vary accordingly, because the total probabilities should sum up to 1, the joint probabilities, right?
Means the one which you have written as 1, that will remain same.
No. I mean, if I add one more column here, let's say y is taking the value 2. Okay. So, okay, wait. Let's not go there. So basically, this is nothing but your fx of 0. And this is called the marginal probability of x for the value 0. So you have fixed your x. So x is fixed, that is 0. And you're varying the value of fxy over y. So for x equals to 0, y was taking the value 0 and 1. Now similarly, if I have to find if I have to find fx of 1, what is this going to be? Fx of 1.
Ma'am, it will be the same, like summation of y is equal to 0 to 1, and f of xy 0, 1 comma 0 and 1 comma 1.
1 comma 0 and 1 comma 1. So here I will write 1 comma y, right?
Yes, y value maybe
Y
0.
varying from 0 to 1. Okay. Now, if I have to find fy of 0, what will you write? What will you write fy of 0 as? Basically, you are adding this probability and this probability.
So I will get f of xj 0, comma 0, then f of x 1, comma 0.
Right? So this is fy of 0. Similarly, you can find fy of y. So these are your marginal probabilities.
Okay, ma'am. Thank you.
Okay.
Hello.
Yes.
Ma'am, am I audible?
You're audible.
Yes, ma'am. I have a conceptual data related to distributions, types of distributions, right? So last Sunday we discussed about 5 to 6 different kinds of distribution. So this
Yes.
is uniform distribution apart, and even for the time being, Poisson also apart. Then I ponder over Bernoulli. So say for example, I'm carrying out a trial, right? And there are only 2 outcomes, success and failure. So if I carry out trial one time, then it becomes Bernoulli. Sorry, yes, Bernoulli, correct. And if I carry out the experiment more than one time, more than two times, then it becomes binomial, right?
Okay. Yeah. Like if you carry out the experiment once, it is a single
I am carrying out
Bernoulli.
I am carrying out an experiment which is having only 2 outputs. Say for example, success and failure, right?
Yes.
So if I carry out experiment only one time, then it is Bernoulli.
A single it is a single Bernoulli. We'll say it is single Bernoulli
right?
trial.
Correct.
Yeah.
And
One
if I
trial.
carry out that trial 2 or more than 2 times, then it becomes binomial. And with NP, like number of trials, and then P is the probability
But
of
in
success.
each of the trial there should be independent, and the probability of success in each of the trial should be same parameter P.
Okay, so then it is called binomial, right? Okay, and then geometric is probability of getting success at a particular number of trials. Say for example, at 6th trial or 7th trial, right?
Yes, yes.
And negative binomial is getting the trial in the first, getting the success in the first trial itself.
Sorry, can you repeat?
Getting success in the first trial itself, it is called negative binomial.
No. Negative binomial is like getting direct success on some kth trial.
Okay,
Sorry,
getting
what?
Getting
Which success?
Rth success. R.
Okay, Rth success. Getting Rth success.
Okay.
Rth success and
kth trial.
Kth
in
trial.
kth trial.
So this all we had discussed in the previous session.
Yes, ma'am.
Yeah.
So this is just a doubt clarification whether my understanding is correct or not. And then the second thing is, ma'am, then doesn't it seem that all these distributions deal with same kind of experiments, like only 2 types of outcomes are there, success and failure, right?
Yes.
So for example, if my experiment is having more than 2 outcomes, then what kind of distributions need to be studied? That is my question. There are 2 parts into my question. First was to clarify my understanding, whether I am going in the right direction or not. And the second question is that if my experiment is having more than 2 outputs, then what kind of distributions we need to study?
So, okay, do you have any example?
Okay, let us start with a very simple toy example itself. I'm having an urn which contains 3 or more than 3 types of marbles, right?
Okay.
And if I'm picking out one by one, then what is the probability? I can get any. Say, for example, let us start with 3 itself. Red, blue, and black, right? Red, blue, and black. Red, blue, and black. Or you can take green so that the initials are different, right?
Okay.
So if I'm carrying out an experiment, red.
Okay, see,
red, green,
RGB. If you want to model if you have a problem of certain kind, you can always model it as Bernoulli. Let's say I have an urn and I know the urn has some red ball, some green ball, and some blue ball. And we know the probability of occurrence of red ball is, let's say, P1, probability of occurrence of green ball is P2, and probability of occurrence of blue ball is P3. Now, if I pick up one ball from here, and if I define my success to getting a red ball,
everything else will be failure.
Yeah, everything else will become a failure, right? So it all depends on how do you model your question. Like if I have modeled my question like I'm defining my success to getting a red ball. So getting a blue ball or getting a green ball is going to be a failure. So again, you have a model where you have a success, you have a failure. Probability of success is fixed.
So again, it is becoming binomial only.
It is again a Bernoulli trial.
Yes, it's a Bernoulli trial, and since I'm carrying out more than one, then it is becoming
So
binomial distribution.
it depends. Right? It depends on the way you have framed your question.
And suppose I want to, I want to capture all three probabilities. Then what will be my distribution? Then what distribution will fit here?
Sorry, you want
I want to capture all three outcomes, all three probabilities, like probability of red, probability of green, and probability of blue. Then
so it is not necessary that all the whatever probability distribution this problem has, like it is not necessary that it should fit into some distribution.
Okay. Because while going through hypergeometric also, that seems also very close to binomial only. Because in hypergeometric, what we say for example, I am having 20 marbles. So out of that,
the only difference there is that in hypergeometric, you are picking up your ball without replacement.
Correct, without replacement.
And in binomial, it is with replacement. That is a major difference.
But in binomial also, where I am doing with replacement.
In binomial, it is with replacement. Binomial, it is with replacement. And
but where I am doing that replacement, because while I am tossing a coin, so there is no replacement kind of thing, no ma'am.
Okay,
while
you're
tossing a coin,
you have a coin
10 times, right? I'm tossing it 10 times, right?
Yeah.
So where that replacement question comes into picture?
You have the same coin, right? You're repeating the same coin.
Okay.
All the trials are independent.
You can understand it using like the difference basically using the bin and ball problems. It is more clear, like how to differentiate between bin, balls and bin. I mean, you have a bin and you have some balls here. How do you pick and how the distribution?
Okay, so that's one of the major difference in binomial. It's with replacement and hypergeometric without replacement, right?
Hypergeometric without replacement, right?
Okay. Apart from it, also deals with only two outcomes. Like if I'm picking out a sample of n, right? So what is the probability of getting certain number of red balls? Right?
Okay, so before you say something else, so what is your doubt? Like, where do you want to go?
My doubt is that all the distributions are getting converged towards only one kind of problem. That's my doubt. So if I have to study other experiments where more than two outcomes are there, then how to model those kinds of problems? That is my.
So you will. I will suggest like first, like you go back and just try to, whatever we did in the last class. You go through all the distribution and look at basic definition, their distribution, and try to like whatever example we discussed that day. Try to find one more example apart from it. So that will help you in understanding the different distributions, that the discrete distribution that we have.
And whatever distributions we have studied so far, 5
we
or 6
had
types.
we had studied first Bernoulli, binomial, geometric, hypergeometric, negative binomial, Poisson,
and even uniform.
We had studied 7 distributions. So you first go, like what you can do is just sit and try to understand what each of the distribution is, and try to formulate one example on your own. Like you look at some situation and try to think of what example can you take. Some very basic, simple examples. That will help you in understanding different, like under what situation you have a particular distribution.
Are these only discrete distributions, or there are more than this? Also?
These are the discrete distributions mostly. The popular one, yes. Okay.
Okay. Thank you, ma'am. I'll do that. In the next session, I will ask. Yes.
Yeah. So
tomorrow we have a session, right, ma'am?
Tomorrow we have a session. Yes, solve with us.
Madam, I have more fundamental question.
Yes.
I've been trying problems, but somewhere I'm missing this point. Like when we have functions like z is equal to x plus y, And we put a conditionality on this. Like let's say probability of x is equal to 0 dependent on z is equal to 1. Let's just say that.
Can you repeat? So you're
Yeah,
saying z
x is
equal
equal to
x
0,
plus y.
x plus y.
Okay.
X plus y.
Okay.
And condition for this probability is z is equal to 1. Let's just say z is equal to 1 on this one.
Okay.
Now, is Bayes' theorem applicable directly? Like if I want to, I don't know for what reason, I saw one of the lectures that sir was actually flipping the conditionality. Like instead of taking it as x is equal to 0 dependent on conditioned on z is equal to 1, he flipped it to z is equal to 1 condition on x is equal to 0. I would like to understand the
Can
advantage.
you tell me like where it is done?
It's in one of
If
the
you
lectures,
remember.
madam. I'm not able to recollect, madam. It is one of the
Because,
lectures that I was
Probably
there.
lecture 2.10.
2.10. Okay,
Yeah.
just
Yeah,
let
I
me
think
check.
so.
It was a cool move, but I just couldn't understand.
Let me
what
check.
exactly.
Maybe some example it
2.10.
has been done. Not sure. Just let me check. It is in 2.10. Very sure.
I don't know in which one I saw, but
I'm
I
not
saw
sure, but I think it is in
flipping.
there. I think I watched it today. So
So 2.11 is maximum minimum.
2.10 is
Is it sum of two independent Poisson
no functions of random variable.
functions of random variable?
2.10.
If you can tell me the lecture number, it will be good.
2.10.
Okay. 2.10. Which part?
Just trying to see in the same lecture. Just
I can't find it. Can you?
yeah. Just trying to actually locate it. Yeah. Can we look at 28 minutes 7
I think
seconds?
it is somewhere in 27.42.
Okay.
28 minutes 7 seconds. There is one instance where he's writing something.
27.48, I think.
Sorry, is the timestamp that you are mentioning? 28 minutes
Yes.
7 seconds. Yeah, that is
So
where the
it is
27,
probability
yeah.
x equal k given z equal to n.
Yeah.
This part.
Yes, yes, yes.
Okay. So okay, I will just show you. I'm not sure what part you're talking about. But, we had probability x equal k given z equal n.
Yep.
Right. So yeah, what is the actual problem here?
No, how did he manage flipping that conditionality there, and like P of X is equal to, X is equal to K dependent on condition on X, Z is equal to N, is becoming P of X is equal to K on product of, is that Bayes theorem that is there in play, is what I want to understand.
Yeah, so we have just used the basic conditional probability formula. So A given B is what? It is probability A intersection B. So it is probability that your X is K and your Z is N, right? And divided by probability of Z equal N.
Yeah, that is the
Now,
first part. Yeah.
that is the first part. Now, this we can write as what? So this
Because
we can,
they are independent, we can actually no.
It is not given that they're
It's not
independent
given.
or dependent, right?
Yeah, it is not given.
So,
No, it is.
It is not given.
Yeah.
So this.
And Y are independent, but Z can be dependent.
Okay. So you know that the joint can be written as product of conditional times marginal.
Conditional times marginal. Okay.
Like I can write fxz, fx given z. Sorry. If x of z, I can write it as, so x of z, I can write this as f z given x times fx of x. We can write this as this, right?
Conditional into marginal is equal to joint. Okay. Yeah. Yep.
Right.
Yep.
So the same thing we have done here. So this is nothing but your joint distribution. The joint distribution that x is taking the value k and z is taking the value n. So this can be written as f of z given x equal k of n times fx of k, isn't it? Right?
Yep. 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 Yeah. I think I just
It is
forgot
clear,
about
right?
the basics altogether. Yeah.
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 Okay.
Ma'am, can you go to the 2532 timestamp?
The same lecture?
Yes, the same lecture. There is something sir has
25, okay. 20, okay, tell me, where is it?
What my doubt is, how did that sigma x is equal to 0 to z, lambda 1, lambda 2 z, lambda 1 raised to x, lambda 2 z minus x, that part became, lambda 1 plus lambda 2 the whole raised to z.
Lambda 1 plus lambda 2 whole raised to z. Okay, okay. The last part.
Yes, the last part of the first question. Yeah.
Okay, so if you look at it, it is nothing but your binomial distribution.
But the binomial has to be, one. It should be like, the probability has to be 1 minus p and p, right?
So your expression was e to the power minus lambda 1 plus lambda 2 divided by z factorial product of z choose x lambda to the power x lambda 2 to the power z minus x. X is varying from 0 to z. Right? So okay.
There's a denominator also which has x factorial times z minus x factorial. Oh no, that's also included in the Z
Yeah,
choose
this
X. Okay,
is
okay.
Z choose X.
Okay.
So this is N choose X, P to the power X. If lambda 2 is lambda 2 equal to 1 minus lambda 1, that is not there, right? Okay,
No.
is okay. So this okay. Can you try to expand it and see how is it? Did you try to say it?
No, I didn't try to see.
Yeah, so I will suggest like you just try to say it once. If you have a doubt, you can also check on the Google.
Okay, okay.
Okay. So first, I will suggest to try to like expand it and see how this comes out to be lambda 1 plus lambda 2 to the power z.
Okay, okay. I'll try to do that. Thanks, man.
Yeah. Okay. Okay, so it's already 10:30 today. So shall we close the session? Rest what? So okay, before we close it, I would like to know how many of you are coming, will be in Chennai for the event.
What event, madam?
Okay, this event that is happening for you all. You're not aware of it?
I did not go through the mail. I saw some message, but when it's read as event, I did not really go through it. Is it some kind of a student meet or something?
Yeah, so a fest is happening for you, all of you.
Okay.
Yeah, it's on Friday, Saturday, and Sunday. So there won't be any session during those 3 days.
We'll have our assignments, isn't it?
That will be, you will get something.
Yeah. I'm in Bangalore, so I don't think I'll be able to make it. I'll be honest there.
Yeah, okay.
And what are the dates we won't have sessions?
This Friday, Saturday, and Sunday. We will not have any
Coming
session.
Friday, Saturday, and Sunday.
Yes.
So will those sessions be taken on some other days?
Yes. So those session will be taken next week.
Will there be any delay in assignment submission?
That all you will get to know.
Thank you.
So coming Friday and Sunday, there won't be any session, ma'am, right?
There won't be any session.
But then again, you will be like Wednesday being the submission date normally that you
Correct.
give. Monday, Tuesday, and Wednesday is when you will have the sessions. That will be too close, isn't it?
We'll schedule the session accordingly. We'll see. Okay. For now, let's just focus till week 2.
Yeah, I mean, this much amount of hand holding and I'm just wobbling. So that's the reason why I'm a little worried.
Okay.
Thank you. Thank you very much.
So yeah, thank you all. So let's close the session for today. So
Thank you very much, ma'am.
yeah,
Thank you, ma'am.
thank you all. Yeah.
Ma'am, for this first 1 to 4 weeks and all like that, which textbook out of 3 textbook we need to follow very closely, ma'am?
So for first 4 weeks, you need to follow Shiva Atyadev.
Thanks.
What about the John Rice thing, madam?
John Rice you can follow from it's just week 7 onwards.
Okay. Okay.
Follow. Yeah.
Okay. Okay. All right.
Okay. Yeah.
Thank you. Thank you very much again.
I'm feeling difficulty to solve the questions.
You just try from the very basic questions, activity problems.
Ma'am, activity questions I have solved all
Okay.
without any help, ma'am.
Yeah, then try for tutorial problems, try for practice assignment problem. There you have the solution already. Try to see different kind of problem and then go for the grid assignment.
Ma'am, mainly I got stuck when there is a distribution. Ma'am, I got stuck. Ma'am, you muted me. Why?
Okay, sorry. I didn't know you were talking. Okay. Many people mic were on.
Okay. Ma'am, when there is any binomial or geometrical distribution is involved in the question, I got stuck with that question. I'm not getting, ma'am, too much example. If I get example of such questions, then maybe I can get it, ma'am.
Example for the distributions.
Yes, ma'am.
So if you want the example for distributions, you go back to week 0.
Which involve, ma'am, which involve random variable, ma'am, functions of random variable. Like, ma'am, today we solved the graded practice assignment question number 6. That type of questions, ma'am.
Yeah, so those are very basic problems. I mean, you just have to use the formula. You just need more practice to solve. So we'll come up with more problems maybe in the next session. We'll do more problem solving kind of thing.
Yeah, that will be really helpful, madam,
Yeah,
because
so we can come up with different kind of problems where you can where we can start from a very basic and we can build it up. Okay, so maybe those kind of session will help you in finding confidence and solving the problems.
when you give a joint distribution table, everything looks nice and easy and
Yeah,
rosy and
everything
all
looks
that.
like nice and
But the
easy.
moment it becomes generic, then game over.
Context based, it becomes difficult. Yeah.
Yeah.
So there also you should try to think if you can put it in the joint distribution table or try to find the range. All this, yeah, you need to solve more problems.
Yeah.
Yeah. Okay. So yeah.
Thank you again.
Let's close.
Thank you.
Yeah.
Thank you, ma'am.
Yeah. Let's close the
I mean,
session for today. Yeah.
we can come to the campus any other day, na? Not only on Paradox.
Not only on Paradox. Yeah, you can visit the campus, but I think you'll have to take permission. I'm not really sure.